Hey, it's Rick here for another video. This is for lesson 6.5, which is on similarity and measurement. And in the last video, we talked about how to make sure that figures were similar, how to write congruency and similarity statements, how to figure out corresponding parts. This time we're going to talk about how, when given similar figures, how do we find maybe some missing side links or things like that. So we're going to start with a very basic shape, and that is a rectangle. And what we're going to do is we're going to put together the information that we've learned about how to do similar figures with our how to solve proportions to answer some questions. Now, generally you'll be given a similarity statement, or it'll say that they're similar. So I'll write out our similarity statement. And you need this to make sure you know which parts match with which. Okay? So given that information, if I am then told that this is 10 centimeters and this is 6 centimeters, and then this is 3 centimeters and this is x, and then I'll probably be told something like find x. Well, here what you're going to do is set up your proportion with the parts of the figure. So I'm going to, do my two fraction bars. And I'm going to take on the left side, usually is where I like to put the one that I do know. Okay. Some people like to put it, the left figure on the left side, the right figure on the right side. Whatever works for you is fine. So I'm going to just set up 6 over 10. You could have done 10 over 6. That's fine too. And then I need to figure out, okay, where do x and where do 3 go? Well, I can see here that CD matches up with GH, and GH is over here. So CD, which is 6, matches up with the 3. So I'm going to write the 3 on top. That's what it matches with. And then this will be x. And we talked about all the different ways that you can solve these, but this is times 2 to go that way. So this must be times 2. Well, what times 2 gives me 10? Well, that would be 5. Okay. All right, so that's a very basic problem when you're trying to figure out similarity and figuring out what is a missing value. What happens, though, if we get a little more complicated? Well, I'll give you an example here. Give me just a second to set ourselves up for a new page. So, what if you're given figures that, look different? Okay, maybe you get something like this. Now with this one, maybe it's kind of hard to tell, especially with my terrible drawings, which one matches with which. And I'm going to name these, we'll name them after some classmates of yours. So we'll do, this is the commie shape. Who else has a 4-letter name in our class? We'll do, this is Zach, spelled with an E, K-H, because we don't want to have any overlapping letters. Okay, so I would need a congruent or a similarity statement here in order to make sure that I end up with things in the right spot. So maybe if I say this is commie, and this information will usually be given to you. You might have the angles marked like in the problems in the previous lesson where you then have to determine the congruency statement, but I'll go ahead and give these to you, and we'll say that this is H, K, E, Z. Okay, so what that tells me is that this shape goes that way, and this shape goes that way. Okay, so we need to make sure we pay attention to that when we're figuring these out. So again, we'd be looking for values. So let's say if this is 20 inches, and if they say this is 30 inches, then let me just come up with some here. Okay, so in this one we can find 2 different missing parts. And again, you have to make sure you match up the right pieces. So I'm going to do 20 over 5 to start. Well, if I do 20 over 5, which does that match with? Well, since it's ZH, I need to look at IC or CI, and that would be 30. So I'm going to put the 30 on top. And HK matches with not 15, but X. And then if I cross multiply, I would get 20X equals 130. So X equals 7.5. And this this particular program doesn't like me to do dots, so 7.5 is what that's supposed to say. And then what about the other way? Well, we'll squeeze it in here down at the bottom, but I can leave my 20 over 30. And this time I'm going to do 15. Well, 15 goes on the bottom because it's on the same side as 30. And Y will go on the top because it's in the same figure as 20. Okay, so when I cross multiply, I would get 30Y equals 300. So Y would equal 10. Okay, so that would be another type of similarity statement you might see. There's one other one where instead of two different figures, you've got something a little bit different. So I will show you an example of that. Usually it's in the form of a triangle. Okay, and so what you notice is that this is a triangle within a triangle. And one thing that will be and especially a focus in geometry is that these kinds of triangles are always similar. And that's because their angles are the same. If this line usually drops down and they say mark these with right angles. And so you can always do these kinds of actions. So if I can do a few different things, okay? I can say, for instance, we might say that this is 16 centimeters, and this is 12 centimeters. And then we could have something like this whole thing is 14 centimeters. So what is X? Okay. Or, you know what? Let's make it a little more challenging. Let's not make this be X. Let's make this piece be X. And we'll see how that changes things in a little bit. All right. So I'm going to match up the pieces. So I know that 16 and 12 go together because they are the long sides here and here. Okay. So I'm going to go ahead and match those up. We're going to say 12 over 16. And then I need to know not X, because X is actually, you know, the leftover on the other side here. I actually need to know this. So I'm just going to give it another letter and figure out what it is. And so it matches up on the smaller rectangle with the 12, and I can put my 14 here. And when I cross multiply, I'll get 16y equals, oh wait, you know what? Rick usually likes for you to do this, and so let's do this. Before I even cross multiply, I am going to reduce this fraction. So this is instead going to be 3 over 4. Well, if that's 3 over 4, instead of 16y, I'll get, sorry, my eraser doesn't work on this program, 4y equals 42. And then when I divide that by 4, what I'll get is, excuse me, I'll get y equals 10.5. Okay, well, that's this section. Well, how would I get then the x? Well, since this is 10.5, well, I just take that away from the 14. So if I do 14 minus 10.5, sorry again, I would get 3.5 being my x. And that's how you would find that. So you can find missing pieces that way. we're going to use this to measure shadows, so this method has multiple uses. But those are the types of problems you're going to be seeing in this lesson, where you find missing values and missing lengths and measurements using proportions and using similar figures. So I hope this was helpful, and if you have any other questions, you can ask one of your teachers when you get to class. Thanks for watching.